In Chapter 3, Section 5, we're looking at domain and range. In a relation, the set of all the values of the independent variable, the x, is the domain. The set of all the values of the dependent variable, y, is the range. The domain describes your input, your x values. The range describes your output, your y values. Give the domain and range of this relation and tell whether the relation defines a function. We're going to use D to describe the domain. Remember, the domain is all of your inputs, and that corresponds to your x values. D, I, domain, input, x values, range, output, y values. So that's one thing to keep in mind when you're looking at domains and range. Input, output, x's and y's. So I'm going to use D to represent the domain and use squiggly brackets to list all of the x values that you can plug into this relation. We're plugging in 3, so I'm listing it with a 3, a 5. We have another 5, I don't need to list it again, and 8. Those are all parts of the domain. The range is all of the output values, your y values. And looking at the output values, I see -8 is one of the first y value I get out, 9, 11, and 15. Now notice that I'm using set notation here, the squiggly brackets, and listing the numbers for both the domain and the range. Well, the original relation was given ordered pairs. Those parentheses indicate ordered pairs, and that's important to keep those in in how you define your relation. Now, in order for this to represent a function, we have to make sure that each x value only corresponds with exactly one y value. So 3 gives you exactly one y value out. However, 5, when you plug in, you either get 9 or you get 11. That's a problem. It's not a function. In order for this to be a function, you want to make sure each individual x value only corresponds with one y value. In this case, we're dealing with a table of values. We can still list the domain and range. The domain is all of the input values. Remember, D for domain, I for input, X for X values. The range is R, the output values, and those are your Y values. So your domain is a set of all the X values that you can plug into this function. The X values are -2, 1, and 2. The range is all of the y values. And here the y values are all 3. And that's okay. As long as you don't have any repeated x values that give you different y values, we can say that this, yes, this is a function. In this case, our relation is given to us as points on a piece of graph paper. You can still find the domain and range and determine if the graph is a function. Remember, D for domain, I is your input, those are your x values, and R for range, O for outputs, and Y for y values. So let's describe the domain looking at the given x values of -3, 0, 2, and 4. Those are your corresponding x values, and then the range are your output values, your y values. So it looks like we have the range here of 2, -3, 1, and -1. Now you may need to put these values in order as they appear on a number line. So it is possible to write this as -3, -1, 1, and 2. Essentially going from the lowest y value up to the highest y value. Is this a function? We say yes, this is a function, because there are no repeated x values that give you different y values. Alright, for this one we're looking at the domain and range here. Remember that your domain is all your input, your x values. Your range is all your outputs, your y values. Now here our relation is given as a graph. So in terms of the domain, we're going to look from the left side to the right side on the x-axis. Remember, D for domain is your x value. So how far in the x direction does this graph go? The x values start over here at, looks like 1, 2, 3, 4, 5, 6, -7, and go over here to +2. So the way we describe our domain is using an interval notation. We can say the domain is everything from this value here of -7 to this value here of +2. We can say x is in between. Using inequalities, we can write it as -7 to +2. Or we can use an interval notation using a bracket here from -7 to +2. That's your domain. The range is your y values, and the y values, you want to look at how low the graph goes, the lowest y value here to the highest y value here. Okay. So on the y-axis, we can determine our range. So we can say our range is all the y values that are between a y value here of -2 to a y value here of +2. We can also use the interval notation using brackets, -2 to +2. Okay, let's look at the next example. Give the domain and range of each relation. Remember, domain is all your inputs, your x values, while your range is all your outputs, your y values. So your domain, this on the x-axis, we see that this graph will continue to go forever to the left. Whoops. Okay, this graph is going to keep going over and over to the left, and it will keep going over and over to the right. So the domain is really everything from everything in that direction to everything in that direction. So if we write this, we can say the domain is all real numbers. Every single x value is represented in this graph. We can also use interval notation to denote that the domain is every single x value possible, starting from left of -infinity to the right of +infinity. Now let's look at the range. The range is going from your low to high. Your y values, your y-axis. This graph continues to go down. We'll go down the page forever and go up the page forever. So in terms of the y values, all of the y values are represented from the lowest y value that's going to keep going down to -infinity to the highest y value of +infinity. So our range is also all real numbers. And using interval notation, we can say the range goes from a -infinity to a +infinity. For domain, you go left to right, and range, you go low to high.